Hi everyone, this is Canixel. Welcome back to episode 2 of our third-person perspective video game development series in Unity, using the visual scripting tool Playmaker. In this episode, we will create the basic player movement system idle, walk and run. The first thing to do is install Playmaker. Before we begin, install Playmaker for commercial project purchased from the Unity Asset Store, published by Hutong Games. After installation, disable the Show at Startup toggle to prevent it from reappearing, and close the Welcome to Playmaker window. Go to Playmaker menu in the Unity Editor tab and dock the Playmaker window in your preferred location. And step 2, create the player FSA. Select your player game object, and this project is Shadow Knight Player. Add a Playmaker FSM component, rename the FSM to Player Movement, and open it. Step 3. Set app input with a new input system. In the FSM's action browser, search for player input get move vector. If you see the error game object requires input system player input component, click the red link to automatically add the player input component. This creates all links to the default input action assets, which is editable in the project setting input system. There is a default binding for each input. For example, move consists of sticky with a keyboard or left stick gamepad. Look have a mouse delta or right stick. So you can check the other actions. Recommendation for Canixel users: the default action works, but our modified version handles run press release events and additional properties more reliably. So leave using the default player input get move vector action, and in the action browser navigate to Canixel's category, add input get move vector, our enhanced version. You can download from the Canixel Asset Store, so you can find the links in the description. We will not configure this at this time, so the first thing to do is we are going to prepare our Animator controller. Step 4. Prepare the Animator controller. Select the Shadow Knight Animator controller, the project window, animation, and player folder. Drag the animation into the controller idle, walk, and run. In the parameter tab, create a new flow parameter named movement. Set simple transitions. So the first thing is from the idle to walk, which is a movement greater than 0.1. So click the disable has exit time for instant response. And from walk to idle, the movement is going to be less, and 0.1 disable has exit time. We use this flow to control blending higher values. The more walk, lower value, more idle. So let's see how we're going to handle with the FSA. And then we are going to add input action and store variables. Now that the animator have the movement parameter ready, go back to the FSA, add the input get move vector action, and the first in the action settings, select the input action reference and choose player move from your input action assets. This tells the action which input binding to read, the WASD or left stick gamepad input. Then configure storage and store magnitude. Create a new variable named input magnitude and stored as a float. Input magnitude is a float, so from 0 to 1, it's an input strings. And when you just talk about input vector, it's a vector 3 variable and a movement direction, which is x if left and right, z is forward and backward, like this. For vector, a new variable, input vector, and stored as a vector 3 variable. The next thing to add is an action named set animator floats, and the parameter is going to be movement, which we have already created on the animator controller, and the value is going to be the input magnitude, which is a float stored in the variable, and this feeds input strings to animator every frame, so controls idle or walk blade. The next action we're going to add is a float compare, and the first float is we have stored an input magnitude, and the float is 0.1. We have already set in the animator controller, and the operation is greater than. When it's greater than 0.1, the transition is going to be to walk. as we have just created on the animator controller. And then every frame is going to be true to just check at every frame, which is about to check constantly. Step 7, configure the walk state. Create a walk state, copy said animator float and float compare from idle, modify float compare, operation less than 0.1 as we mentioned and as we do on the animator controller, and less than event is to idle. Add a smooth look at direction, and the target direction is the input vector. Let me explain. Input vector is a vector tree float, so hold as a direction. Example, forward is 0, 0, 1. So smooth look at direction use it to gradually rotate player, which is a smooth and natural facing. Let's test this, and top-down view, move and walk blend plus rotate correctly. The next step we are going to do is add run functionality. Now that idle to walk and smooth rotation are working perfectly, let's add running. First, in the animator controller, create a new parameter bool named basic run. Add transition between walk to run and run to walk. Walk to run basic run is true and has exit time is false. Run to walk, the basic run is false and has exit time is false. Why separate bool? The movement float is already handling the blend from idle to walk, which is the idle 0 and walk is 1. Run is a different animation, not just faster walk. Though we use a bool for clean yes or no state switch. This keeps logic simple. Float is speed or blend, bool is sprint state. Now go to the FSame in the walk state using input get move vector, detect run performant left shift key, send event run when pressed, create new run state, transition walk to run on event run. In run state, copy all actions from walk, input get move vectors, and smooth look at direction. On run wheels, detect in input get move vector, send event walk, transition back to walk. Add said animator bool, and the parameter is basic run, and bool value is true, and every frame is true. This activates the run animation while we are in this state. Select that said animator bool action, copy it, then switch over to your walk state and paste it right here in the actions list. Now change two things. The first, set the value to false, and second, make sure every frame is also turned off. Why both? Because in the walk state the player is not running, so we only need to turn this bool off once when we enter the state. We don't need to keep forcing it false every single frame. At this point, hold the left shift, should switch to run animation and keep moving, rotating correctly, and release left shift should return to walk animation. We will notice and fix one small bug later during full testing. Here we are. Set up third person camera. Create an empty child under player and name it camera follow, which is a position offset, and duplicate this camera follow game object and rename it to camera controller. And move outside the player. And make the main camera the children of camera controller game object. And reset the camera, and you can assign the view perspective of this camera by pressing Ctrl, Shift, and F together to align the camera to the scene view. On the camera controller, add FSame and rename camera controller. And the first state, you can name it camera and add an action from the Canixel categories, input mouse look. And the user owner object is the camera controller, and the sensitivity as you want, On the X and the Y, you can adjust this 3 and 3 and choose a look action from the input action asset, which is a delta pointer and a mouse. And let's test that how the mouse look is working. And then you can add an action move toward this. The owner object is what? The camera controller. The target object is the camera follower we have created as a children in the player. And we will make the finish distance from 1 to 0, because when you make it 0, it's gonna be non-stop. So it's follow the player always. And taste the mouse look and the camera follows, and it's good. The last thing to do is make movement camera relative. So now that camera is following and looking, but let's make movement relative to camera direction. It's not working. So go to player movement if same in the walk and run state. On input get move vector action, set relative to main camera. Test move forward, rotate camera, character move toward the camera view, and perfect realistic third-person feel. Now we are going to fix a bug we have discovered during testing. During testing, run fully stop, no input. Sometimes run animation keeps playing in the idle. Fix the idle state. Add set animator bool, and you can copy from the walk, which is the parameter is basic run, but the value must be false. And test again. Run, stop, and idle plays correctly, no run bleed. Finally, just to polish and transparency fix as is the player body's transparency glitchy, yeah. So select the materials and make the render face boss, not front. And final test, everything works. Idle, walk, run, smooth rotation, camera relative movement, and proper follow. No bugs. And that's wrap for today's episode. We have got our walk and run states locked in perfectly in the animator with the balls behaving just right. Now you might be wondering why haven't we added the actual character controller component yet? That's because the real challenge comes next when we start hooking up jumping, landing, and all the other animations, then blend them seamlessly into the player's movement so everything feels smooth, responsive, and natural. In the next video, I will show you step by step how we are going to integrate the character control properly, blending the jump and the other animation beautifully. Avoid the most common mistakes people make and use the smartest, cleanest approach so our player feels amazing to control. If you're enjoying this series, give this video a like, drop a comment about what kind of game you are building, and subscribe so you don't miss the next part where our character finally starts jumping and moving like a pro. Thanks so much for watching. See you next one.